Hello and welcome to Introduction to Functions. This is a GCSE video to help you deal with functions problems. So, what is a function? Well, a function is just a way of taking inputs and changing them to an output. So, you have dealt with functions your whole life, we just haven't called them functions. So, for example, if you go into the shops and you're going to buy some tins of beans cost 30p. And we want to know, well, how much does it cost to go to the shops to buy those beans? I tell you, you've got to buy 7 tins of beans. So our cost would equal the number of beans, number of tins I'm going to write actually, right, times 30p. Oh, that's way too much writing for maths. Okay, let's redo that. Let's just say that C equals 30n. There we go. That is a function. Right? It's just us writing this long bit out, but instead of having to write it all those words out, we can just write C for cost equals 30, because it was 30p each, times n. That's it. That's all a function actually is. Okay? Right, moving on to the second bit, domain and range. The domain is the numbers that we've put in, so they are our input values. Right? And the range the values that we get out. So yeah, they're the values we get out. Okay, now we're going to use these quite a lot, and you just need to know mathematical words and what they mean, because we're becoming more and more technical as we go through. It's also useful later on when we do inverse functions, which you'll see at the end of this video, because what we're going to do is we're going to swap our domain and range, right? But I'll cover that properly then. Okay. Third point, mapping diagrams. Now, mapping diagrams are just a way to try and help you visualize functions. So what they do is they take the value and your input values, your domain, right? So let's have a look at, imagine I put in 0, 1, 7, or in fact x. Okay, and we go, well, what do they go to? Okay, for our function, we times by 30, right? That's what our function actually is. Our function says times by 30. Okay, so 0 times 30 is 0. 1 times 30, 30. 7 times 30, 210. X times 30, 30x. That is what a mapping diagram does. It just says, I'm going to take this number, I'm going to apply my function to it, and get it to that number. Okay? So this really is stuff that you have done before. We are just pinning it down in mathematical notation. The reason we're doing that is because when we deal with far more complicated things, like we will deal with a GCSE, we don't want to have to write down half a page of writing to explain it. We want to just be able to put down a few symbols, you to understand it, and deal with it. At the core of things, we're really lazy as mathematicians. We don't want to write that, we want to write that. So, let's pin down a bit of what that notation is. If I write fx like this, I am saying this is a function of x. Okay, so I'm going to do something to x. So I might have 30x plus 5. Okay, similar to our original function that we looked at earlier. Up here, I've just got an additional plus bit. Okay, that is a function. We can have another function. Sometimes we have to have multiple functions in one situation. G of x, that equals 2x squared plus 7. We might have a third function, h of x, which might equal 2x plus 1 over x minus 7. Okay? All we are saying here is whatever our input value is, x, we're going to, in this case, we're going to times it by 30 and then add 5. In this case, we're going to square it, times by 2, then add 7. In this case, this is a lot more complicated. We're going to do 2 times our original function plus 1, and then we're going to divide that by our original number minus 7. Okay? And this is the sort of reason why we don't want to have to write the whole thing out in words. We want to be nice and lazy and just put it in this notation. Okay? That's the start of things. I'm now going to show you the sort of questions that we might have. Okay. So, let's say we're given the value of a variable, right? We're told, all right, for the function f of x, for f of x, x equals 2. Way too much writing, okay? The way we write that is just f of 2. So what that means is we're going to plug 2 in wherever we had x. So that will be 30 times 2 plus 5. And that's going to equal 65. Okay? So if you're ever asked to find f of a number, what that means is put that number in where x was and times out, multiply, divide, whatever, to get your answer. Okay? I can do that with g of x, so I might write g of 3, and that would equal 2 times 3 squared plus 7, which would be 2 times 9 plus 7, 18 plus 7, 25. Okay, see, yet again, I've just plugged in my number. Okay, that's how you deal with those questions. Next style of question, finding the value of the variable from the function. So let's say I know that f of x is, I don't know, 95. Way too much writing again. What I want to write is this. F of x equals 95. Okay, so what that means is that 30x plus 5 equals 95. Take away 5, 30x equals 90, so x equals 3. And we've been able to find our value of x from that. Again, we just don't want to have to do much writing, and so we use this notation to simplify things. Okay? And our final thoughts are composite functions. Alright, actually no, we've got inverse as well. So, composite functions. Right. I'm going to show you the notation first here. Right, I might write fgx. fgx. Now lots of people get confused with this. They go, oh, fgx, I'm going to times f by g. Look, there's nothing in between, it's clearly times. That's not it. What we mean is f of g of x. So, f of x was 30x plus 5. I'm going to write that down again so we don't forget it. F of x was 30x plus 5, and g of x was 2x squared plus 7. Okay? G of x was 2x squared plus 7. So what this is saying is we're going to plug g of x into f. So actually we've got f of 2x squared plus 7. Right? Now, it's in this bracket here, so that means wherever we have wherever we have x in here, we're going to plug this. So this equals 30 lots of 2x squared plus 7, then add 5. Now you can see that this has replaced x because it's in here, and that's gone into there because it is f of g of x. Okay, so now all we have to do is times this out. So it becomes 60x squared plus 210 plus 5, so it's 60x squared plus 215. Another way we might have seen this was we might have seen gf1. Okay, again we're going to do g of, but this time the f's on the inside, and it's f of 1. So we go, what is f of 1? You plug 1 into this equation, you get 30 plus 5, so it'd be 35. So f of 1 is 35, so now we get g of 35. Right, that's not a particularly nice question now. So that equals 2 times 35 squared plus 7. This is definitely a calculator problem. And that equals, when you plug it through a calculator, 2,457. Okay. Right. Last thing for this video. Inverse functions. Okay. So the inverse means it does the opposite. The opposite of timesing by 2 is dividing by 2. The opposite of adding 6 is taking 6. We want to do the opposite thing. For easy examples like that, you can just see it. For a slightly harder example, like f of x, you can't. Well, I can't. Right? So when we write an inverse function, the notation is this little tiny -1 up there. Right? Inverse of x. That's what we want to find. Okay? So what we do is we start with f of x. So f of x equals 30x plus 5. Then instead of having f of x, we're going to write y. This is, again, it's just a simplifying thing. We don't want to have to play with this f of x everywhere all the way through. So y equals 30x plus 5. Now the next thing we're going to do is we're going to swap x and y around. Okay? Now this may seem a bit weird, but bear with me on this. So we are trying to change the input values to be the export values, the values that come out. Now normally y is the value that comes out and x is the value that goes in. So when you swap it, they'll be swapped around. So just change all the x's for y's. So we get x equals 30y plus 5. Note, the numbers in front haven't moved. I've literally just changed that y into an x and that x into a y. Okay, now we want to rearrange this equation to get y equals again. So I'm going to take 5, x minus 5 equals 30y, then I'm going to divide by 30. X minus 5 over 30 equals y. Now that I have rearranged this for y, I want to put it back into function notation. But it's not going to be f of x, that was what the original. This is going to be the inverse f of x, what we were looking for originally. X minus 5 over 30 equals f to the minus 1 inverse of x. And there we go. I hope that was helpful.